Yeah, good morning, all. We'll continue our session. In the last class, we have discussed data link layer. In the data link layer, we have seen two parts or two different categories or two subparts are available. One is data link control, another one is multiple access control. So data link control we have seen in the last class. Now we will move to the multiple access control. In the multiple access control protocol, we have several categories available. Normally, broadly, it will be categorized under three categories. One is called as random access protocol, second one is controlled access protocol, third one is channelization protocols. So random access control protocols, under that we have four different categories or four different subdivisions available. One is called as Aloha, second one is CSMA, carrier sense multiple access, we'll call it as carrier sense multiple access with respect to collision detection, carrier sense multiple access with respect to your collision avoidance. So these are all the four different categories that is available under random access protocol. And one more thing, one more important concept that we need to know about random access control protocol is the station randomly can access the channel. Any station, if it is a shared channel between four stations, means any channel can access that particular channel at any time. Any station can access that channel anytime. There is no restriction or waiting time. You need to wait certain amount of time so that the other party can send the data. Once they finish off, then it will be given it to you. No such things. Any person can actually use the channel at any time. That is the only thing that we need to just remember when we are going with random access protocol. Under that, we have seen Aloha. Aloha has been split into two parts, and that means two subcategories are coming under the Aloha, which are those pure Aloha and slotted Aloha. Pure Aloha, in that we have seen that at any time, any particular time duration, any particular packet or the frame can be sent to the other party. Since the channel is one and the same, we are using the same channel. If the one particular station wants to transmit a frame, before it gets transmitted, the other frame is ready, means then both the things are involved in collision, both the things are collided, then it will be lost. So always the vulnerable time with respect to your pure Aloha is two times of t frame. So that's how it will be taken with respect to your vulnerable time of the pure Aloha. This diagram, the procedure for pure Aloha, we have already seen that. Once again, I won't repeat it. So we'll just quickly move on to the next one. So we left out in the last class where to calculate the throughput for the pure Aloha. What does this throughput means? Throughput plays a vital role in any network performance issues. So based on this throughput, latency, and several other properties, we'll say how efficient the network is. So throughput, what it is meaning? See, I have sent so many packets to the other particular end, or I have sent so many data to the other end. But whether all the data, whatever I have sent, is received properly in the good condition with respect to the receiver end, that is my question. How much will be received? That will be nothing but your throughput. I'll say that all 100 particular data bits I have sent it. Out of 100 bits, if only 5 bits are correctly received at the receiver end, then our throughput will be 5. Understanding it? So how many will be received? Depending on that, the throughput will be decided. See, I may transmit n number of packets, n number of data bits in the same channel. Out of that, how many have been survived? Say, for example, with respect to the previous example itself. See here, with respect to the station 1 is sending frame 1.1 as well as 1.2. Station 2 is sending 2.1, 2.2. Station 3, 3.1, 3.2. Similarly, station 4, 4.1, 4.2. See, with respect to this particular, each station is sending two frames. Four stations are there, so totally 8 frames are there. Out of this particular 8 frames, only 2 frames will be survived, that is frame 1.1 and frame 3.2. So throughput is only 2. So this is what throughput is all about. So for calculating the throughput with respect to your pure Aloha, they have given one formula, that is S is equal to, S is nothing but your throughput, so is equal to G into e to the power of minus 2g. What is this g? G is nothing but the average number of frames generated by the system during one frame transmission time. What do you mean by one frame transmission? So when you are constructing a frame, when you are making that particular frame to transmit from one end to another, and during that time, how many such frames can be generated on an average? How many frames are generated by the system? That will be nothing but your G. See, that one we need to take it. So with respect to your maximum throughput, with respect to your pure aloha, if you want to achieve it, then G should be 1 divided by 2. That means maximum number of packets, or whatever the percentage, it will be measured in terms of percentages. So whatever the S max is there, so if you substitute G is equal to 1 by 2 over here, then S max will be 0.184. That is 18.4 percentage of the actual, how many frames that you have generated, among them 18.4 will be surviving in the channel. Remaining all will be collided and it will be lost. So this is what the meaning of this particular number. So we'll quickly move on to the next slide. See here, we have taken an example how to explain that particular throughput. Based on that, what are all the analysis that we can make it. See, a pure Aloha network transmits 200 bits frames on a shared channel of 200 kbps. Shared channel. So that means the channel is shared between 4 or 5 or some, how many? We need to just look into it. So 200 bit frames I need to transmit it on a shared channel of 200 kbps. The whole particular bandwidth of the channel is 200 kbps capacity. So what is the throughput if the system produces 1000 frames per second, 500 frames per second, 250 frames per second? So that means, so what will be the throughput that I need to just calculate it? So for that, first I need to go with the transmission time. So the frame transmission time is calculated by using this particular 200 bit frames followed by shared channel is there, right? So between that, if you just apply one particular formula, how many how many bit frames that you have? 200 bits divided by what is the shared channel capacity? 200 kilobits per second. So with respect to that, you'll be getting the transmission time. So that is nothing but your 1 milliseconds. That is what it is having. So if the system creates 1000 frames per second, 1000 frames per second, if it creates, means this is nothing but 1 frame per millisecond. So with respect to this 1000 frame is nothing but 1 frame per millisecond, it will be just calculating. So based on that, the load, that is the G value, average number of frames that you will be getting it for transmitting one such particular thing is nothing but here 1. G will be 1 with respect to this. If you substitute the value, then S becomes 0.135 with respect to this. So what is the formula for calculating the throughput with respect to your pure Aloha? It is S is equal to G multiplied by e to the power of minus 2G. So with respect to that. So this means that the throughput is 1000 multiplied by 0.135, that is 135 frames. 135 frames will be survived out of 1000 frames, whatever you will be generating it at the sender end. Out of 1000 packets, out of 1000 frames, 135 frames will be survived in the channel. Remaining all will be collided and it will be lost. Understanding it. Similarly, with respect to your 500, then G becomes 1 by 2 of it. That is, half of it will be reduced. So 1000 frames for that 1 means 500 frames out of that, the load will be 1 by 2. 250 frames, 1 by 4. Depending on that, the value will be, you'll be getting it. So 500 into 0.184, that is 92 frames will be survived. And this is the maximum throughput case with respect to your percentage wise. So similarly, with respect to your 250 frames, if you are just saying it, but G becomes 1 divided by 4. With respect to that, S becomes 0.152. That is 15% of your actual value will be just sent on the other side. That is 250 into 0.152. That is 38 frames only will be survived with respect to your out of 250 frames that you have generated at the sender. So this is what it is. So just to overcome it, see, we were having some problems with respect to a pure Aloha. What are all the problems? So we were not knowing when the particular packet has been started and when the other station need to send the other packet. See, there was no slot. So with respect to its particular time, whenever the station wants to send it, it was sending the data. So even if the other station was engaging the channel to transmit it, because the channel is shared one, right? So anybody can use it. So without knowing that, somebody starts once again. Once at the, even if the particular frame is at the end of that particular transmission, if it is, if another frame will start or begin the transmission, means then both the frames will be lost over there. So that is what the scenario is. So just to avoid it, what they have done is they have fixed some particular slot based on that particular pure Aloha network. Based on that only, they have worked on it. They decided that just to overcome this particular when the frame has been started or ended, just to avoid the collision between them, what they have done is they have made the slots. With respect to this slot, in this slot, you need to just send the packet. See, there is a collision happening with respect to this, but when compared to your previous pure Aloha, see here with respect to your frame 2.1 and frame 3.1 followed by frame 1.2 and frame 4.1 will be getting collided. In the same particular duration, it will be transmitted. So there is nothing like it has been begun at the some other particular time. Before ending it only, you have transmitted the other particular frame itself. So time slot will be given. During this particular slot, anybody can utilize it. If one person is utilizing, it is not saying that other person cannot utilize. If he survives, or if he want to transmit the data, if it is not surviving, if he wants to transmit, if some other particular person wants to transmit the data, then both the things will be collided and it will be lost. It is as good as our particular classroom environment. See, we have created a particular timetable. Based on the timetable, one particular class, one particular room will be reserved for one particular class. One particular faculty will engage for a given time slot. In one time slot, one person, one course, they can just give the lecturing, and based on that, students can also learn on it. If I say one particular entire particular column, if I just say it, three columns are there in the entire particular classroom. So three divisions. With respect to each division, one class, if I just have it, then what will happen? Whatever the words that has been delivered from course 1 to course 2, course 3, course 4, everything will be collided and nothing will be taken from your taken as an output from the courses. So that is what it happens. So those things I need to eliminate it. But when compared to your pure Aloha, the survival rate with respect to number of frames, that the throughput is high when compared to your pure Aloha. Why? The entire slot will be taken into consideration as one particular vulnerable or collision duration period. So between that, you need to just finish off. After this, you can survive as many packets as you want. See here, frame 1.1, 2.2, followed by frame 4.2, followed by frame 3.2. All these four frames will be survived along with respect to your slotted Aloha. When compared to your pure Aloha, it is a better one, but still you cannot avoid the collision in this particular protocol also. The vulnerable time is nothing but the duration of the transmission of the frame. Whatever the transmission time of the frame is, that is nothing but your vulnerable time with respect to your slotted Aloha. When compared to your throughput is calculated with respect to S is equal to G multiplied by e to the power of minus G. That's it. There's no 2G. Understanding it? Minus G is the value that you need to just go with it. The maximum throughput with respect to your slotted Aloha can be achieved when the G value is 1. That is, whatever the transmission, or G is nothing but the average number of frames that you can transmit, or it will be generated by the system during one frame transmission time, right? So during that one, it should be transmitting. So one frame you need to have it. On an average, one frame need to be there available. So with respect to that, yes, maximum becomes 36.8 or 37 percentage, or 36.8 percentage is the guarantee that it will be giving you. So those many frames will survive always out of that particular thing. If we apply the same particular formula, or with respect to this, if I just start calculating with respect to the previous example that we took with respect to your pure Aloha, same thing. If we just try to allocate with respect to the slotted Aloha, then the frame transmission time is 200 by 200 kilobits per second, that is 1 millisecond. If the system creates 1000 frames per second, that is, this is nothing but 1 frame per millisecond, that is G is equal to 1 frame per millisecond, it will generate That is what it will be just seeing it. So with respect to this particular scenario, this is the maximum throughput that it is achieving. That's what they will be saying it, right? So in this case, S is equal to G into e to the power of minus G. G becomes 1 month, 36.8. So 36.8 percentage of frames will be survived. That is what it means. So this means that throughput will be nothing but 1000 multiplied by 0.368. That is nothing but here 368 frames will be survived in the probable list. So this is what. So G becomes half of it. That is 500 frames. If you are transmitting means G becomes one, that is half of that particular load. So with respect to that, it can have 30.3 percentage of survival rate. It can have it. So with respect to this 30.3 multiplied by 500, it will be giving you 151 frames. So out of 151 frames, you can just survive. Out of 500 frames, you can survive 151 frames. Compare it with respect to your pure aloha. It is always more. 92 was the thing that we were getting it with respect to your pure aloha concept with respect to the load as half of it. If it is 1/4 of it, then it can survive 49 frames out of 250 frames probable survival. So this is what it means with respect to your aloha concept. Next, in all the aloha concept, whatever the pure aloha, slotted aloha, there were no sensing activity itself. We were not asking the other station whether we are not asking the channel itself whether the other station has been utilized or not. That was a problem that we have faced with respect to your first random access control protocol that we have seen, that is Aloha. In order to overcome it, what they have done, we will be just going with respect to your one more random access control protocol itself. Randomly, any station will be transmitting it, but before transmitting, what I'll do is I'll use one particular mantra, listen before you talk. That is carrier sense multiple access is all about. So the mantra is very simple. You need to listen to a particular person before starting your data transmission. So that means whether it is in the idle state or busy state, the channel, depending on that, I can transmit it. If it is in the idle state, then I can transmit it. If it is in the busy state, then I cannot transmit it. So this is the simple funda that they have just changed with respect to your second random access control protocol called as CSMA. CSMA stands for carrier sense multiple access. Whatever the thing or whatever the sensing element that we will be just introducing, but still it is not enough to completely avoid the collision. Collision will happen. So how it will be happening? For better understanding, we need to just take an example. So here is an example with respect to your collision and CSMA. See here, so lot of things that is happening with respect to this particular slide. So if you are thinking that A, B, C, D or 4 stations available, B is able to transmit or B is just sending some messages during the time duration T1. What it is doing, it is just transmitting, it is just asking, broadcasting a message saying that, are you busy? Is the channel utilized by station A, station C, station D? If the channel is not utilized by any of the other stations other than B, then B thinks that nobody is using that particular channel. I am easy to, or I can easily transmit, or I can easily use that particular channel for transmission. I can easily utilize the channel for transmitting the frames. So with respect to that, it starts. So once it starts, it will be taking some time. See here, this is the propagation time that we need to have it. So since it reaches to the station A, this is the time that it will be taking it. So during this particular duration, everywhere, so this is where your B will be transmitting the data. Similarly, your B will be transmitting it to the other particular station also, station C. But see what happens in the C. So at the duration time T2, before this particular B reaches to C, at the time duration T2, what it will be doing is C will start analyzing the channel, whether it is idle or busy. During this particular duration, the channel is still idle because B has not sent any particular messages during this particular duration of the time. So at this particular point of time, what the C will be thinking is, still the channel is idle, so I can also transmit it. So it starts transmitting it. During the propagation, there is a delay in that particular propagation period. With respect to this, it starts transmitting it. Once the B channel is also sending the signal and C channel is also sending the signal, then the collision happens. And thereafter, whatever the signals that has been transmitted, this is where the collision will be happening. So this is the duration where you will be just not getting any type of collision. This is with respect to your B transmission. This is with respect to your C transmission. So this is nothing but you cannot avoid this black colored signal because your signal will be losing. You'll be losing the signal at this particular point of time. That's what the problem that we are having with respect to your CSM. Although it has asked, B station has asked the channel whether it has been utilized by some other person. Since it has given the answer as idle, it has started it. C also has not done anything wrong. It has also broadcasted a message. It has also censored the channel. So channel is idle, so that's why it started. But before the C started, B has already been starting its transaction. So with respect to this particular transmission, so somewhere in the middle, both of the signals will collide, and every particular signal after that will be collided, and the entire signal will be lost. So you'll not get the entire particular packet over here. So collision-free network you cannot imagine at all. That is the simple funda that you need to just have it in your mind. So this is with respect to a collision in CSM. What about the vulnerable time? Vulnerable time is the affecting time. So that is nothing but your propagation time. Whatever the frame propagation time is, that is nothing but your vulnerable time. So since it's, suppose a frame A wants to transmit a frame from the station A and it need to reach to station D. So till it reaches, till all the particular entire scenario, once it starts, till it reaches to your D station is nothing but your vulnerable time, because in between B can sense, C can also have sense. So if both the things will sense means, then it will be lost in between. So that's why until it reaches to your destination, the entire time duration is nothing but your vulnerable time with respect to CSM. In order to make our, we need to have a sensing element, right? So for doing that, we have one particular terminology called as a persistence method. What is this persistence method? It is nothing but it will give you whether the channel is idle or channel is busy. Just to identify it, we have identified one particular technique called as persistent methods. Under this particular persistent methods, there are three different categories available. One is called as one persistent, second one is called as non-persistent, third one is called as p-persistent. What is this? All these particular persistent is all about. One persistent, what it will be doing is, it will always try to send a signal from the transmission. Once the sender is ready, once the station is ready to transmit the frame from its end, it starts sending a signal. It will not transmit the frame directly. It will start sending a signal. What is that signal? That signal is nothing but the sense signal. So continuously it starts sending the signal to the channel. If it is busy, it will not respond. Until and unless it won't respond, you need to just continue your sending the same sense signal. Once the signal is once the particular channel responds to your signal, that is okay, I'm able to listen because I'm idle, so that's why you can just sense and transmit the data. So once it is given the green signal, then the transmission happens with respect to your one persistent. Non-persistent, I'll send a sense signal at one particular duration of the time and I'll keep quiet. If it is busy, I'll keep quiet. I'll not do anything. After a few minutes, randomly I'll pick the time. After a few minutes, once again I'll just check whether the person is busy or the channel is busy or not. After a certain amount of time, if that particular thing is still busy, means I'll wait for a longer time. So 3 minutes I have waited, I'll wait for 4 minutes. In that particular 4-minute duration, if it finishes off with respect to your 3-minute duration itself, still I'll need to wait for another 1 minute. That's the buffer time. I have randomly picked that particular time. After finishing that, then I'll just send the same particular signal once again. So if the signal is sent and it has been responded as idle, means then I'll say that sense and transmitters happening over there. This is called as non-persistent. Whereas the last one, p-persistent, it's a combination of your one persistent as well as non-persistent. What is going to happen? In the P persistent, what happens with respect to the beginning, the channel, the station, whichever is ready to transmit, it will ask the channel by sending a sense signal always. One, within a no time, it will start sending the signals. If it is busy means it will start sending that particular signal within no time itself, until and unless it sees that the channel is idle. Channel may be idle for a certain particular point of time, but still it may be occupied with some other particular scenario. Within a small duration of time, it may just go, or it may be occupied by some other particular person. During this particular duration of time, what happens? Nothing can be done. You need to keep on waiting until you get a green signal saying that I'm completely idle. You can transact, you can continue your transaction. That is, you can continue transmitting the particular data. So till that one, you need to keep on waiting in the P persistent. This is what it happens with respect to your persistence methods. Just to have a brief introduction, we need to just look into this particular flow diagram. Will be coming to, or it is better to understand with respect to the flow diagram. So that's why one persistency here, channel. I have a question mark. Random. Why diamond symbol is there? Because I'm asking a question. With respect to that, if it is busy, once again transmit the same signal once again. Otherwise, if it is idle, station is ready to use. So you can just station will be ready and it can transmit n number of frames over there with respect to that particular channel. Similarly, for non-persistent channel, it will be just asking whether it is idle or busy. If it is busy, wait randomly. Once again, retransmit the same particular signal. Once the signal is saying that I am idle, then station can transmit n number of frames. The third one, that is P persistent. First, the channel, if it is asking for whether it is busy or idle. If it is busy, once again you need to transmit the same particular signal. See here, combination of these two will be nothing but this one. See, first one is channel. It is asking whether it is busy. Busy means keep on sending the same particular signal. So loop on that particular thing. No need to wait for a certain amount of time. Once it is done, next one is if it is idle, it will be transmitting. But what happens if it is probable, if any particular thing comes into picture in between? Say for example, yes, I said it is idle, but still it has been occupied by some other particular person and during the particular duration of time. What happens? I need to just wait for that particular slot. How it will be done? It will be just taken with respect to your one of the particular number by using the probability outcome. Whatever the probability outcome is there, depending on that, it will be just doing it. So if the value, whatever the probability outcome is less than or equal to P, then station can transmit. If it is greater than P, then you need to wait. Wait for a time, and then you need to check once again whether the channel is busy or idle. If it is idle, once again it will be sent to them. If the probability is less than that particular value, outcome is less than the P value, then you can just send it for transmission. Otherwise, you need to back off that particular process. So once it is busy means you need to do the same particular task oftenly right from the beginning. So this is what it happens with respect to your P persistent. So with this, that is the end of your CSMA. But what is main important thing that you need to concentrate is, so okay, I have sensed the particular channel station, whether it is utilizing or whether I'm sensing the channel, whether it has been occupied by some other particular station is going to transmit the data or not. I'm just checking it. Suppose something goes wrong, so collision is detected. So for that, how to detect it? For that, we need to go with CSMA bar CD. Collision, since that is carrier sense multiple access, we are doing that. After doing that also, if the collision happens, means what happens? You need to abort the complete frame. You have to retransmit it once again. How to do that? We'll just see it in the next slide. See, CSMA, it is nothing but carrier sense multiple access with collision detection. That is what CD is all about. How this particular thing done? I will just try to continue. Okay, so this is nothing but here carrier sense multiple access with collision detection. So this one, in the station monitors the channel when while sending a frame. Station monitors, that is, yes, at the station T1, sorry, at the station A, B, C, D is stations. T1, T4, T2, T3 is nothing but the time duration that we are using it. See, what is time T1 and T4? What is T2 and T3? You need to just analyze it. Before analyzing, suppose we think that station A is been started, or it has been it contains, or it contains several frames need to be transmitted through the channel. For doing that, what it will be doing is it will check whether any particular neighboring stations is utilizing the channel or not. How to do that? For you, by using the any persistent methods, it will be doing it. Whether the station is idle or busy, one persistent, p persistent, or non-persistent. Any one terminology you can just apply it. Once it says during the T1 nobody has started, just check out with respect to this now. Nobody has started during the time duration T1. Yeah. During this time, nobody has started. So channel is idle. So I can utilize it. So for doing that propagation time, it requires some particular time, right? So during this is nothing but your propagation time. So this particular time, during this particular propagation time, anything can happen. So that is the vulnerability that we have just sensed with respect to your CSMA, right? So that is very, very important. What happens? T1, it has been started. It will be just transmitting that particular thing. T4 during this particular time, and T2 is available. That is your next time duration. With respect to this particular next time duration, whatever your particular C channel is, C station wants to use the channel, during that particular duration, it will sense that particular channel. See, with respect to this also, since it has been started, it has not reached the station C. So with respect to this, station C thinks that the channel is idle. So with respect to this, it starts transmitting that particular thing. So the propagation time will be this particular local area. Understand? So now, just imagine, see here, station A is transmitting the data, station C also transmits. At one particular point of time, you will be getting a collision. So this is where collision happens. If the collision is detected, then you need to abort the entire particular process. You have to retransmit the frames right from the frame A till the frame D is reached, followed by right from the frame C, that is whatever the station C wants to send the particular frame, that one also you need to just retransmit it once again. If the collision is detected anywhere, understanding it. So this is how the collision detection happens. To understand it better, we'll just take a diagram with respect to that. It will be easier for us to understand. So for better understanding, we need to analyze this flow diagram. What is this flow diagram? It looks similar to your pure Aloha, whatever the flow diagram that we have seen it. So what it will be doing, once the particular station is ready to transmit the frame, it need to sense it with respect to the channel that it is shared among the many stations. So with respect to that, K becomes 0 at the beginning. What is K? K is nothing but the number of attempts that we are just moving in. So with respect to that, it will apply whether whether I can use that particular channel or not by using any one of the persistent methods. Carrier sense, multiple access, persistent methods. Once it gives a green signal saying that channel is idle, it is eligible for transmission, then it will enter to the next block. Next block says it is a question mark once again, whether the transmission can be done or transmission done or collision detection. Collision detected. Both the particular questions answer. If it is yes, then it will move to the next outside block called as collision detection, because anyone can be done. See, transmission, if it is done means properly without collision also, it will enter to that particular block. If the transmission is not done but collision is detected also, it will be entering to that particular block. Transmission done but still collision is detected also, it will be entering to this particular block. Whichever the collision is detected, collision as detection happens means if it is no collision happening, then success. You can just transmit that particular entire thing. If the collision happens, then you need to say you need to send a transmission signal. That signal is nothing but a jam signal. That means you need to abort that. You need to say that it need to be aborted. For doing that, you need to send a signal, and you need to make that attempt may be equal to one value next to that particular previous one, whatever the attempt value that we have taken. That is a K value. Now there is a always there will be a one particular scenario we need to take it. We cannot say it should continue always, because the same scenario, if it repeats for n number of times, means it's of no use to doing that. So just because of it, the number of attempts that we will be just normally comparing is whether it is greater than 15 or not. If it is greater than 15, then you need to abort the entire process. The complete scenario is wrong. You need to change the entire scenario itself. Design should be changed. That's what it says. If it is no, then you need to choose a random number between the value 0 and 2 to the power of k minus 1. Any value, you can just choose it. So from that particular value, you need to multiply the maximum propagation time that it is required, followed by, or else you can do it in another way. So you need to multiply the random number, whatever you have chosen, with respect to the average transmission time that is required for a frame to transmit. So this is also done. Both the things, any one, you can just use it. What is this particular value, whatever the output that you are getting is nothing but the back of time, we'll say it, or else you can also call it as waiting period or waiting time. So that many time I need to wait for the another frame to transmit, or another attempt if I want to make it, means I need to just suppress it over that. So this is what it will be meaning with respect to your CSMA CD. Understanding it? So this will happen with respect to your thing. Once it is done, same thing. You can transmit the data to the next particular step. Are you getting this? So the same thing will be repeated n number of times. So if you want to just take it in the other particular manner, say for example, what I want to do is a very simple terminology. If I want to analyze the CSMA bar CD collision detection, if I want to do it, means then if I take the same scenario, or if I take the same particular flow diagram with respect to our examination point of view, you are entered to the first semester, you are ready to give the exam, that is your first attempt. So K becomes 0. Understanding it? Once it is done, it will be asking. So, okay, are you ready to take the examination? If you are ready, you can transmit that particular thing. If you are eligible, you are just going to do it. If any particular thing wrong, or if any particular, while filling the form, if you are doing some wrong thing, means it need to be taken care at the beginning itself. With some fine, once again, you need to just apply it. And once the application is accepted, it will be taking it to the next step. Next step is you will be whether you have passed the examination or not. If you have passed with no particular hurdles, then success. Otherwise, if a failure is happening, then you need to reattempt or reconsider or retake that particular course itself. Once again, you need to attempt for it, and then you need to just complete it. How many times you can attempt it? Maximum, you may get a chance of completing your entire BE course for 8 years, not more than that. Twice that particular number of years that you require to complete it for one particular normal duration time. So 4 years is the normal duration time. 8 years you can just take it. After 8 years, you need to abort that particular course. You need to choose a separate course. That's what it is meaning. Till how many time you need to wait? You need to wait till the entire semester is over. Then you can take the one more attempt, right? So that's what it is. Simple example that you can just look into it. And this is a simple scenario I have given you. So anything you can just take it. So it all works with respect to the same particular scenario. Okay. This is with respect to your CSMA series. We'll stop here. So the rest of it CSMA CA will continue into the next class.